Hi, I'm Ryan Nickel, CTO at DSA Ocean, and today I want to talk about verifying reserve buoyancy or net buoyancy of a surface buoy in ProteusDS when you're working with the rigid body buoy model. So in one of the other video tutorials, we talked about setting up a more complicated buoy model with a rigid body buoy to capture the rotation effects. Maybe you've got more complicated geometry and so on. And this was inspired by, in the other example, the Fugro Sea-Watch LiDAR buoy. So generally speaking, it's pretty nice buoy for simplicity. It's got sort of a cylindrical shape. There's a little bit of a keel, and I've modeled this with a cylinder hull here as well. I've added a little bit here for the keel too. So you've got your rigid body buoy. The way that the rigid body model works though is that you specify hull geometry here, and then you also give the mass properties. So these are approximations. It's not the real buoy. It's not a real buoy configuration. It's just kind of eyeballing it, based on the numbers you see publicly available. And here we have some inertia values. Now there's two features here for the cylinder, and you can kind of see how they're configured here with the main hull. And then I've got a little smaller one here representing the keel. That little soccer ball thing, this is the center of gravity as well for this rigid body. So you specify the mass, you specify the shapes, the sizes, the diameters, and the lengths of those shapes. And then a common question is, well, how do I verify what the actual uplift of the buoy is, given all these parameters? This requires a bit of checking and iterating on it a little bit. So now this is an approximation. It's not the exact same dimensions. It's about 2.8 meters diameter and 1 meter length. We'll see, yeah, that's the case here. And what I'm going to do is, if we look at our water surface, we're basically going to guess and check. So what I'm going to take this buoy and I'm going to dunk it, and we're going to run a real short simulation. So there's our water surface. What I actually want to do is put it totally under the water surface. So there's no currents, there's no waves. I'm just putting it below the water surface. And we'll make sure we're running a really short simulation, and we're just going to look at the resulting forces. So if we go back and look at this in the results, here as our simulation folder, LiDAR buoy, that's the name of our rigid body. And we go to look at, this is the global force accumulator acting on it. Now the only thing is really, because there's no currents or anything like that, and it's not moving at the initial time, is that's going to be the net buoyancy force. Now this is in newtons. You kind of just move the decimal place over 1 to get a quick kilogram force equivalent as a quick check. Now for this case, I think we were sort of aiming for a net buoyancy around 2,500 kilograms. So this is kind of heavier than that. It's sort of closer to 5,000. And I haven't tried to tune this or adjust this or anything like that. Just generally looking at the buoy, it's kind of got a conical lid and it's a little bit more slender than that. So maybe here's where you might make an adjustment if you've got a simple approximation. Maybe you're using a custom mesh, but maybe we're just doing a really quick exercise here. So the diameter is going to be good because that's sort of the outer diameter. Maybe what we'll do is just decrease this a little bit. We have sort of, it's a bit more, sort of looks a little bit more appropriate. The cylinder's not attached there. We can adjust that later. I just want to go through this process really quickly. So it's still dunked. And we'll go back to our results and LiDAR buoys, the rigid body results folder, and we'll look at forces.dat. Oh, I've already got it open in my notepad++ here. It says, do you want to reload it? Yeah, we want to reload it. So we're looking at time in the first column, X and Y global forces. Those should pretty much be 0, and they are. And then we have the net uplift here, 26,000 newtons, or basically that's 2,600 kilograms net uplift. So so it's going to start moving because I haven't fixed it in place. So things will start accelerating. There's drag. Ignore this at the first time. This is going to be your net uplift value. So it's a little bit crude, but it's a quick, and it's still relatively quick to verify what that net uplift is. And then you've got confidence in your rigid body configuration. You've got it set up the way that you want, and you move on from there. All right, that's all for now. Thanks for watching.